Okay, so the next question that we have is question number 20, and I made a mistake. I looked at the answers and I was trying to differentiate the answer, which of course doesn't make any sense. But for around 8 minutes I was trying to do that, and it was actually not very easy because the answer was a little bit a long function. So anyway, now I'm back to the questions. Now the question is basically you want to differentiate d by basically this function, which is a plus b times sine x, over c plus d times cos x. This is also something that might come in handy sometime. A plus b times sine x plus c plus d times cos d. So what you can do is that you can use u divided by v whole prime is equal to u prime times v minus u v prime divided by v squared. So you can write this as basically d by dx of a plus b times sine x times the function in the denominator, which is c plus d times cos x, minus the first function, which is a plus b times sine x, times the derivative of the second function, which is c plus d times cos x. And you want to divide that by c plus d times cos x whole squared. Now the derivative of a plus b times sine x is equal to d by dx of a plus b times sine x is equal to basically d by dx of a plus d by dx of b times sine x. This is equal to 0. And this is b times cos x. So this is b times cos x. So you have b times cos x times c plus d times cos x, and you want to subtract from that. You want to subtract from that this function a plus b times sine x multiplied by the derivative of this function, which is negative d times sine x, over c plus d times cos x whole squared. And then you can probably, I don't know really, but let's see. So this is e times bc times cos x plus bd cos squared x minus a negative a times d sine x and negative b times d sine squared x, and you want to divide that by c plus d cos x whole squared. So you can write this as bc cos x plus bd cos squared x plus negative into negative is positive ad sine x plus bd sine squared x over c plus d cos x all squared. Now you can take a basically between this term and this term, you can take a BD out and write it as cos squared x plus sine squared x, which is equal to 1, plus BC cos x plus AD sine x over c plus d times cos x all squared, which is the same thing as basically BD times 1 is BD plus BC cos x plus AD sine x over c plus d times, c plus d cos x whole squared. That is the derivative of your function. This is cos. So the answer is BC cos x plus AD sin x plus BD c plus d times cos x whole squared. So that means that basically if you have d by dx of, which could happen not that often but probably so, which you have if you have d by dx of a plus b times sin x over c plus d times cos x. If you want to differentiate this, you will get basically this expression over here, b times d plus bc cos x plus ad sin x over c plus d times cos x whole squared. That's basically the whole story. Whether or not you can use it anywhere, I don't really know, but that's how you differentiate this function. Now the next question that we have is question number 21, which is sin x plus a over cos x, and you want to differentiate this function, d by dx of this function. Now to differentiate this function, what you need to do is again the same story really, meaning that you have u divided by d, you have u divided by v whole prime, which is the same thing as u prime times v minus u v prime over v squared. Now so if I want to calculate, I think that the derivative of sine of x plus a is cos of x plus a. I think so, but I'm not really sure. So we will have to calculate that. But the derivative of cos x, we know it's negative sine x, so that's no problem. So we'll have to use the first principle in order to calculate this this derivative, and then we will be able to put the whole thing in this formula. So if you have basically d by dx of sine of x plus a, so you know that's basically meaning that if your function is, meaning that suppose that you have a function f of x, for example, is equal to sine of x plus a. Now you know that your d by dx of f of x is equal to, which is f prime of x, is equal to the limit of basically h tends to 0 of basically f of x plus h minus f of x over h as h tends to 0. So if you calculate f of x plus h here, you will get f of x plus h is equal to basically sine of x plus h plus a, and that's it. And f of x you already have it, h is already a, so you don't have to worry about anything here. So that means that d by dx of f of x is equal to the limit of sine of f plus h, sine of x plus h plus a minus sine of x plus a over h as h tends to 0. And that is equal to, so you can write this as to cos sine. So you know that sine x minus sine y is equal to 2 times cos x plus y divided by 2 times sine of x minus y divided by 2. Which means that, well, you can write this as the limit of basically 2 times cos, now x, this is x and this is y, so you have x plus h plus a, x plus y divided by 2 would be x plus h plus a plus x plus a all divided by 2, which is 2x plus 2a plus h divided by 2. So that's 2x plus 2x plus 2a plus h divided by 2 times the sine of basically x minus y divided by 2, which is x plus h plus a minus x minus a divided by 2. And this is negative x, negative a, and that is h divided by 2 over h as h tends to 0. Okay. Now I can rewrite this as the limit of basically sine of h divided by 2 over h divided by 2, because this 2 can come to the denominator and this becomes h divided by 2, and then I can multiply that by the cos of 2x plus 2a plus h as h tends to 0. And then you can rewrite this limit as the limit of this part times the limit of this part as h tends to 0, and the limit of this part as h tends to 0 becomes 1. So this part becomes 1. The limit of this part as h tends to 0 becomes, and there is a divided by 2 over here as well. And then the limit of this part as h tends to 0 becomes the cos of 2x plus 2a divided by 2, which is the same thing as the cos of x plus a. So that means that d by dx of sine x plus a is equal to cos x plus a. Okay. So that's basically the first part. Now the second part, of course, is easy. There is no problem with it. So the function that we had was basically we wanted to calculate d by dx of sine of x plus a over cos of x. And we said that we would use the use u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So then you can rewrite this as u prime, which is d by dx of sine x plus a, which is basically cos x plus a, times this function over here, cos x, minus u, which is sine x plus a, times the derivative of the second function, which is negative sine x, divided by cos squared x, which is basically just this thing over here. You cannot simplify this really any further. Number 21. It seems that you can do something to this. But how? It seems that it's possible to simplify this thing. Let's see. So if I multiply cos x plus a times cos x minus sine x plus a, I see, okay. So over here what we have is cos of x plus a times cos x, and negative into negative is positive, plus sine x plus a times sine x, okay, divided by cos squared x. Now you know that cos x minus y, you know that cos x minus y is equal to cos x cos y plus sine x sine y, right? So here you have cos x cos y plus sine x sine y. These are the exact same angles. So I can write this as cos of x minus y, meaning that cos of this whole numerator becomes cos of x minus y, which is x plus a minus x, which is equal to cos of a. So this is equal to basically cos of a over cos squared x, which is the answer that you find in the book. So that's basically that. Okay, so that is that. The next question, number 22. Okay, so the next question that we have is, we want to find the derivative of, we want to find d by dx of x raised to the power 4 times 5 times sine x minus 3 times cos x minus 3 times cos x. So you know that basically u times v whole prime is equal to u prime times v plus u times v prime. So this is equal to basically d by dx of x raised to the power 4 times this function over here, which is 5 times sine x minus 3 times cos x minus 3 times cos x plus u, which is x raised to the power 4 times d by dx of 5 times sine x minus 3 times cos x minus 3 times cos x. So d by dx of x raised to the power 4 is equal to 3 times x raised to the power, 4 times, is 4 times x raised to the power 3 times 5 times sine x minus 3 times cos x plus x raised to the power 4 times d by dx of this is equal to basically 5 times cos x plus you have a negative 3 times cos x and d by dx of this. So you would write this as basically d by dx of 5 times sine x minus 3 times cos x is equal to d by dx of 5 times sine x minus d by dx of 3 times cos x. Now, d by dx of 5 times sine x is equal to 5 times cos x. 5 times cos x. And minus 3 times cos x would be the derivative of cos x is negative sine x, so that's negative 3 times sine x. So that's equal to 5 times cos x plus 3 times sine x. So 5 times cos x plus 3 times sine x. Plus 3 times sine x. So you have basically 20 times. I don't think you're supposed to simplify this. I suppose not. Number 22, x cubed times you can. It seems that you can simplify it. So you can write this as 4 times x cubed times 5 times 5. It's 20 times x cubed sine x minus 12 times x cubed times cos x plus 5 times x raised to the power 4 times cos x plus 3 times x raised to the power 4 sine x. And so you can take x cubed out. So you can write this as x cubed times 20 times sine x minus 12 times cos x plus 5 times x times cos x plus 3 times x times sine x. So you have x cubed times 5x cos x, 3x sine x, 20 sine x, and negative 12 times cos x. Number 23. Number 23 is x squared plus 1 times cos x. So you want to calculate d by dx of x squared plus 1 times cos x times cos x. So again, you have basically basically u times v whole prime is equal to u prime times v plus uv prime plus uv prime. So you can write this as d by dx of x squared plus 1 times cos x plus x squared plus 1 times d by dx of cos x. Now d by dx of x squared plus 1 is 2x is equal to 2x times cos x, and that is x squared plus 1 times negative sin x, which is, I suppose, that's so if you can write this as basically 2x cos x minus x squared sin x minus sin x. Now number 24, you have d by dx of ax squared plus sin x times p plus q cos x. P plus q cos x. And you want to find the derivative of this function. Again, u times v whole prime is equal to u prime times v plus uv prime. So you can write this as d by dx of ax squared plus sin x times this function, which is basically p plus q times cos x plus u times, which is ax squared plus sin x, ax squared plus sin x times d by dx of p plus q p plus q times cos x. So d by dx of ax squared plus sin x is equal to 2 times a times x, and the derivative of sin x is basically cos x times p plus q times cos x plus ax squared plus sin x times p plus qx. So the derivative of p is 0, then the derivative of q times cos x is negative q sin x. So I don't know if they have simplified this. 24 negative q times sin x times ax squared plus sin x and 2ax plus cos x times p plus q times cos x. That's your answer. There is no point in simplifying it. Number 25 is x plus cos x d by dx of x plus cos x x minus tan x. So again, you can write this as d by dx of x plus cos x times x minus tan x plus x plus cos x times d by dx of x minus tan x. X minus tan x. So d by dx of x plus cos x is equal to d by basically 1 minus sin x times x minus tan x plus x plus cos x times 1 the d by dx of tan x is I suppose tan x secant squared x or something like that. D by dx of tan x is secant squared x. So minus secant squared x. Okay, so that you can write as I don't, let me see if they have simplified this. Negative tan squared x plus cos x, x minus tan x, 1 minus... Okay, so you know that 1 minus secant squared x, you know that sine squared x, you know that sine squared x plus cos squared x is equal to 1. Now, if you divide... If you divide by cos squared x, you will get sine squared x by cos squared x plus cos squared x by cos squared x by cos squared x is equal to 1 over cos squared x. 1 over cos squared x, actually. And this is tan squared x plus 1 is equal to secant squared x. So that means that secant squared x minus 1 is equal to tan squared x. Secant squared x minus 1 is equal to tan squared x. Over here what I have is 1 minus secant squared x. 1 minus secant squared x. So 1 minus secant squared x, this is secant squared x minus 1. So what that means is that I can write this as negative of secant squared x minus 1 is equal to negative of tan squared x. Or if I multiply this negative sign, you will get 1 minus secant squared x is equal to negative tan squared x. So now 1 minus secant squared x is equal to negative tan squared x. So instead of this, I can write negative tan squared x. Negative tan squared x. So that is that. Now number 26 is 4x plus 5 sine x is you want to calculate d by dx of 4x plus 5 times sine x over 3x plus 7 times cos x. Now you know that u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So you can write this as 4x, or d, basically d by dx of, you can write this as d by dx of 4x plus 5 times sine x times v, which is this function over here, which is 3x plus 7 cos x minus 4x plus 5 times sine x times d by dx of basically 3x plus 7 times cos x over v squared, which is 3x plus 7 times cos x whole squared. So this is equal to basically d by dx of 4x plus 5 times sine x is equal to 4 plus 5 times cos x, and over here you have 3x plus 7 times cos x, and over here you have negative 4x plus 5 times sine x, and over here you have basically 3 minus 7 times sine x over 3x plus 7 times cos x whole squared. I think we can simplify this a little bit. 26. So I can write this as, for example, I can write this as 12x plus 28 cos x plus 15x cos x plus 35 cos squared x minus 12x minus 28x sin x and then you have 15 times sin x minus 35 sine squared x over 3x plus 7 times cos x whole squared, which is the same thing as 12x plus 28 cos x plus 15x cos x plus 35 cos squared x minus 12x plus 28x sin x minus 15 sin x plus 35 sine squared x. And then in the denominator you have 3x plus 7 times cos x whole squared. Now over here you will get basically 35 times. So for example, you have cos x. I don't have any cos x over here, so I can write it as it is. And 12x and negative 12x you can cancel out. 15x cos x, I cannot do anything with that, so I can write it as 15x cos x, and then over here I have 28 minus 28x sin x, 28x sin x, and then over here I have negative 15 sin x, and then over here I have plus 28 cos x plus 28 cos x, and then over here I have 35 cos squared x plus 35 sin squared x. If I take it 35 out, I will get 35 times cos squared x plus sin squared x, which would be 1 basically, so that's just plus 35. So these two will be also 35. Will be also 35. And then you have in the denominator we have 3x plus 7 times cos x raised to the power 2. So I suppose that's the answer to number 26. 35 plus 15x cos x plus 28 cos x plus 28 cos x. Okay, 15x cos x, and then you have 20x sin x, 20x 28x sin x. This one, negative 15 times sin x over 3x plus 7 cos x whole squared. That's the answer. 27 is 27 is x squared times d by dx of x squared times cos of pi by 4 divided by sin x. Okay, so you have u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So you can write this as basically u prime d by dx of x squared times cos of pi by 4 times cos of pi by 4 times v, which is equal to sin x minus u times u is x squared times cos of pi by 4 times d by dx of sin x divided by v squared, which is sin squared x. Now again, this is a constant. Cos of pi by 4 is just simply square root of 2 over 2, right? Cos of pi by 4 is equal to square root of 2 over 2. So you can treat this as a constant and write this as basically 2 times, so d by dx of x squared times cos of pi by 4 is equal to 2 times cos of pi by 4, 2 times cos of pi by 4 times x. So you can write that as 2 times cos of pi by 4 times x times sine x minus x squared cos of pi by 4 d by dx of sine x is cos x. Divided by sine squared x. Divided by sine squared x. So I suppose that's the answer there. So you can, of course, it seems that you can simplify this, meaning that you can write this as 2 times cos of pi by 4 times x times sine x, for example. 2 times cos of pi by 4 times x times sine x minus cos of pi by 4 times x squared times cos x over sine squared x over sine squared x. And so you can take an x out, you can take cos pi by 4 out. So x times cos of pi by 4 times 2 times sine x minus x times cos x divided by sine squared x. Divided by sine squared x. 2 sine x times cos. Number 28. Number 28 is number 28 is d by dx of x divided by 1 plus tan x. So you can write this as, again, u divided by v whole prime is equal to u prime times v minus u v prime over v squared. So you can write this as d by dx of x times 1 plus tan x minus x times d by dx of 1 plus tan x over 1 plus tan x whole squared. So d by dx of x is equal to 1. So that's basically 1 plus tan x. And that is x times d by dx of 1 is equal to 0. D by dx of tan x is equal to d by dx of tan x is equal to secant squared x. So that's secant squared 0 plus secant squared x over 1 plus tan x whole squared. So you have 1 plus tan x minus x secant squared x over 1 plus tan x whole squared. I suppose that's the answer there. 28, 1 plus tan x minus x secant squared x. So you can write it as, for example, 1 plus tan x minus x secant squared x over 1 plus tan x whole squared. Number 29. Number 29, you have d by dx of x plus secant x plus secant x times x minus tan x. So u times v whole prime, u times v whole prime is equal to u prime times v plus u v prime. So that is equal to d by dx of basically x plus secant x times x minus tan x plus x plus secant x times d by dx of x minus tan x. So d by dx of x plus secant x, d by dx of secant x is equal to secant x tan x. d by dx of secant x is equal to secant x tan x. So this you can write it as 1 plus secant x tan x times x minus tan x plus x plus secant x times d by dx of x minus tan x is equal to 1, and d by dx of tan x is equal to secant squared x. d by dx of tan x is equal to secant squared x. So that's 1 minus secant squared x. 1 minus secant squared x. So that's the same thing as basically x minus tan x x plus x times secant x tan x minus secant x tan squared x plus x minus x times secant squared x plus secant x minus secant cube x minus secant cube x. So over here you have x minus tan x plus x times secant x plus tan x plus secant x tan squared x plus x minus x secant squared x plus secant x minus secant cube x. Okay, so this these two you can basically, these two you can add together. You will get a 2x there, negative tan x. You can simplify this a little bit. For example, tan x you can take out from these terms, and secant x you can take out from these terms. But let's see how they have done it. They have written it as x plus secant x 1 minus secant squared x see. Okay, so it seems that it's really not necessary to do this step. You can leave it as it is at this step, and because there is no way to simplify it any further. Okay, so question number 30. Question number 30 is x divided by, you want to calculate d by dx of x divided by sine raised to the power n of x. So what we showed before was that d by dx of sine raised to the power n of x was equal to, I don't remember really what that was. It was n times sine raised to the power n minus 1 of x times cos x. This was d by dx of sine raised to the power n of x, and we proved this, right? So now here you have d by dx of this function, which is the same thing as u divided by v whole prime, is equal to basically u prime times v minus uv prime over v squared. So you can write this as basically d by dx of x times sine raised to the power n of x minus x times d by dx of sine raised to the power n of x divided by sine raised to the power n of x whole squared. So you can write this as, so this is n times basically d by dx of sine raised to power n of x is equal to n times sine raised to power n minus 1 of x times cos x. Okay, I have to erase it really, but for now I can keep it over here for now. Let's see what happens. So this is equal to basically d by dx of x is equal to 1. So you have sine raised to the power n of x. Now sine raised to the power n of x, we said it's equal to minus basically n times, so here you will get n times sine raised to the power negative sine raised to the power n minus 1 of x times x. So I can write, and then you have one x over here, so you have n times x times sine raised to the power n minus 1 of x times cos x over sine raised to the power 2n of x, over sine raised to the power 2n of x. Now here you have sine raised to the power n of x. Here you have sine raised to the power n minus 1 of x. So I think you can take that out. Let me see how they have done it. If I take sine raised to the power n minus 1 out, if I take sine raised to the power n minus 1 out, let's see what happens. I have sine raised to the power n minus 1 of x out. And then I will get, basically over here, I will get sine raised to the power sine of x, basically. Because sine of x times sine raised to the power n minus 1 of x is going to give you sine raised to the power n of x. And over here you will get n times x times cos x. And over here you will get sine raised to the power, let's write this as, I'm going to write this as sine raised to the power n of x times sine raised to the power n of x. So over here I will have sine raised to the power n of x times sine raised to the power n of x. Now if you simplify this with the denominator, you will get basically sine n raised to the power sine raised to the power n. You can write it as sine of x. This you can write it as sine of x times sine raised to the power n minus 1 of x, which will be sine raised to the power n of x. So I rewrite this term as this, and then you can cancel this out with this one. So this would be sine raised to the power n plus 1 of x. These two, if you add them, multiply them together, you will get sine raised to the power n plus 1 of x. So these two will be cancelled out, and so you will have basically sine of x minus n times x times cos x over sine raised to the power n plus 1 of x. That is the derivative of this function, x over sine raised to the power n of x. That is your answer. Okay, so we are done here. The next thing that we have, the next chapter of this book that we have is basically called, the next chapter is chapter 14 of this book, chapter 14 of class 11, which is about mathematical reasoning. So in the next chapter we will talk about mathematical reasoning. So I will see you in the next basically series of videos. Thank you.